Hi guys. So this video is optional. This is for those of you guys who really have been doing well with that Gauss-Jordan elimination. I want to show you guys how you can actually use Gauss-Jordan elimination to help you find the inverse of a 3x3 matrix. Now, in this class, I'm always going to let you guys just use a calculator to find the inverse because, again, this is a lot of extra work and a lot of extra steps and usually some pretty ugly numbers. And there's also more than one way to find the inverse of a 3x3, but this one I think is just related the most to what we've been doing. So if you want to find the inverse of a 3x3 matrix, one of the things that you can do is you can basically write the identity matrix next to your original matrix. So here is my original, and I'm just going to draw a line here so I don't get too confused, and I'm going to write the identity matrix, which has the triangle of zeros in the top and the bottom. And then what I'm going to do is the same process that we did last class with Gauss-Jordan elimination. But I'm going to apply whatever those row operations I did to this side, I'm going to apply those same row operations to this side at the same time. And when I'm done, basically these two things will be flipped and you'll have your inverse. All right, so what we're going to do, again, whenever we did that Gauss-Jordan elimination, we tried to get our zeros over here. Well, I've already got one zero, so that's good. But let's go ahead and get another zero. So I'm going to go ahead and get this zero, because that one's going to be pretty easy. I can do that by adding 3 times R2. So top row has not changed. Second row has not changed. Negative 3 plus 3 is 0. So 4 minus 12 is a negative 8. 1 minus 6 is negative 5. I'm also going to apply that same operation to this side. So 0 plus 0 is still 0, 0 plus 3, and then 1 plus 0. And then we're just going to continue this same process until I have this in that reduced row echelon form on the left side. All right, so now next step, we already have 2 zeros, so let's go ahead and try and get that third zero. So I'm going to go ahead and just get this one. I think that one's just going to be a little bit easier because it's already in that bottom setup. So in order to get that one, not a very pretty operation, but I can subtract 8/3 times row 1. And I'll probably run out of space, so let me rewrite it down here. So first row is not changing. Second row is not changing. Bottom row is changing. So I'm going to have 0, 0, 1/3, negative 8/3, 3, and 1. All right, so now at this point, I'm going to go ahead and swap. So I've got 1, negative 4, negative 2. All right, and now I can see I just need to get those ones. So let me go ahead and get those ones here. So in order to get those ones, I'm going to multiply by a negative 1/3. And I'm going to multiply by 3. Top row is not changing. So I've got 0, 1, 2/3, negative 1/3, 0, 0, negative 8, 9, and 3. All right, so now at this point, I'm pretty close. I just need to, again, this has to be in Gauss-Jordan elimination to be able to find your inverse. We have to have it in reduced row echelon form. So let's keep going. Let's get another 0. I'm going to go ahead and get that negative 4 and turn that into a 0 by adding 4 times row 2. So I have to zoom out quite a bit to see this. Sorry, guys. So I'm going to do 1 plus 0, negative 4 plus 4, negative 2 plus 8/3, And the same thing for this one. Negative 1/3 plus 0. Then I've got, I don't have negative 1/3. Sorry about that. So I've got negative 4/3. And I've got 1 plus 0 and 0 plus 0. Sorry about this. I'm struggling to see both these. It's struggling to see one and right in the other because I'm zoomed in quite a bit here on my side. All right, now we have not changed the second row. So that's 0, 1, 2/3. Bottom row has definitely not changed. That's our good row. All right. Now at this point, we're almost there. So at this point, I really just need to get those 2/3 down to 0. I'm going to go ahead and do this at the same step just to kind of save some space because I'm running out of room. I'm going to subtract, I don't know why I wrote narrow. I'm going to subtract 2/3 row 3. I'm going to do that to both of these. So 1 minus 0, 0 minus 0, 2/3 minus 2/3. 0 minus 0, 1 minus 0, 2/3 minus 2/3. Bottom row hasn't changed. Then same operation. This is where it gets a little ugly. So then I've got negative 4/3 minus 2/3 times a negative 1/3. Sorry, negative 4/3 minus 2/3 times negative 8. So add those together, and that's going to put me at 4. Then I've got 1 minus 2/3 times 9. So that gives me 1 minus 6, which puts me at negative 5. Then 0 minus 2/3 times 3, so 0 minus 2, which is a negative 2. All right, then the second one. So negative 1/3 minus 2/3 times negative 8. So that's going to put me at 5. 0 minus 2/3 times 9 is going to be a negative 6. 0 minus 2/3 times 3 is going to be a negative 2. And the bottom row has not changed. So now, what you've done, you've gotten the left side into a reduced row echelon form, which means what's left here on the right side when you're performing those operations is the inverse of the original matrix. So you guys can probably see why this isn't required in this class. I'm going to let you guys use a calculator, find those 3x3 inverses, but it does kind of show you how these two things do tie together. If you end up taking a linear algebra course in college, this will come back and you'll see it kind of in there. But for this class, this is really just a little extra extension for you guys to see. So your final answer here, the inverse of that matrix would be 4, negative 5, negative 2, 5, negative 6, negative 2, negative 8, 9, 3. And that's the inverse. And again, there's other methods of getting there. I think this one just ties the best into what we've been doing.